Well, we're nearing the end of our study of quadrilaterals. So we've talked about parallelograms, and we've talked about a special kind of parallelogram, a rectangle. And today we're going to talk about rhombi and squares. Rhombi. What are rhombi? The rhombi is plural for rhombus, and that's where we're going to start today with the rhombus. Here we go. A rhombus is a parallelogram with four sides congruent. And again, because it's a parallelogram, it has opposite sides are parallel, opposite angles are congruent, opposite sides are congruent, consecutive angles are supplementary, and the diagonals bisect each other. We get to add two characteristics today, though, that are special to a rhombus. One is that the diagonals are perpendicular, and another is that each diagonal bisects a pair of opposite angles. So let's put these properties to work. If dk equals 8, we need to find KL. Well, remember, all four sides are congruent. So if dk equals 8, well, KL equals 8. And we're done with that one. Okay, if the measure of DML equals 82, find the measure of DKM. We know that opposite angles are congruent, and we know that the diagonals bisect opposite angles. If the measure of DML is 82, we know that DKL is also 82. DKM is then half of that, which is 41. If the measure of KAL is 2x minus 8, find x. Well, we know that diagonals are perpendicular, which means that 2x minus 8 equals 90. So we can solve for x, and x equals 49. What if dA is 4x and AL is 5x minus 3? We're going to find the whole diagonal of DL. We know that the diagonals bisect each other. Therefore, we know that 4x equals 5x minus 3. Solving for x, we get x equals 3. We also know that DL is 2 times DA. If DA is 4 times 3, then we know that DL is 24. If DM is 5y plus 2 and DK is 3y plus 6, we need to find KL. We know that the four sides are congruent. Therefore, we know that 5y plus 2 equals 3y plus 6. So we can solve for y. Now, if we put y back into the equation for dk, we can find that dk equals 12. Since all sides are congruent, that means KL is also 12. Now, I told you we were going to talk about rhombi and squares. Let's talk about squares. A square is a parallelogram with four sides congruent and four right angles. A parallelogram that is both a rectangle and a rhombus is also a square. Check out this Venn diagram. It's a good illustration of what I just said. Because a square is also a rectangle, a square has congruent diagonals, just like a rectangle does. So we'll put these characteristics into practice. If MNPQ is a square, we need to find the measure of MNA. We know that a square has four right angles and that the diagonals bisect the opposite angles. So we know that MNP is 90 degrees. We know that MNA is half of that, or 45 degrees. Now for a bit of a challenge. We're going to take a set of vertices and determine whether QRST is a rhombus, a rectangle, or a square. Here are our vertices. So let's get those graphed. We'll connect the dots. And what can we see from this graph? We can see that all the sides are congruent. We can see that all the angles are 90 degrees. So we know that it's a rectangle, we know that it's a rhombus, and it's a square. Rectangles, rhombis, and squares, oh my, but they're all part of the parallelogram family, just kind of different pieces and parts of it. Thanks for coming.